This is SpaceTime, Series 28, Episode 4, for broadcast on the 8th of January 2025. Coming up on SpaceTime, more evidence that dark energy might not exist after all. New observations show the solar winds slowing down beyond Pluto, and Venus's ancient layered folded rocks are pointing to a volcanic origin. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new paper claims that one of the biggest mysteries in science, dark energy, doesn't actually exist. Now, if correct, it would force scientists to begin looking for new ways to try and explain the accelerating expansion of the universe. For the past 100 years, physicists have generally assumed that the cosmos is growing equally in all directions. They employed the idea of dark energy as a sort of placeholder to explain the unknown physics behind this, which they simply don't understand. The thing is, this contentious theory's always had its problems. Now, a team of physicists and astronomers from the University of Canterbury in Christchurch, New Zealand, are once again challenging the status quo, using improved analyses of supernova light curves to show that the universe is expanding in a more varied, lumpier way. The new evidence supports something we've talked about before on SpaceTime and on Star Stuff before SpaceTime, namely the concept of Timescape, a model of cosmic expansion which doesn't have the need for dark energy, because the differences in stretching light aren't the result of an accelerating universe, but instead a consequence of how we calibrate time and distance. Timescape takes into account the fact gravity slows time, so an ideal clock in empty space would be ticking faster than one inside a galaxy. The model suggests that a clock in the Milky Way galaxy would be about 35% slower than the same clock in an average position in a large cosmic void, meaning billions more years would have passed in the voids. This would in turn allow more expansion of space, making it seem like the expansion's getting faster when such vast empty voids grow to dominate the universe. Now, once again, the scientist behind this study is Professor David Wiltshire, who's led previous research into timescape and dark energy. Wiltshire says the new findings confirm earlier studies that we don't need dark energy to explain why the universe appears to expand at an accelerating rate. He says dark energy is simply a misidentification of variations in kinetic energy of expansion, which is not uniform in a universe as lumpy as the one we actually live in. And the new research may provide compelling evidence that could resolve some of the key questions around some of the quirks of our expanding cosmos. See, with the new data, the universe's biggest mystery could be settled by the end of the decade. The new analysis has been published in the monthly notices of the Royal Astronomical Society letters. Dark energy is commonly thought to be a weak anti-gravity force which acts independently of matter and makes up around 2/3 of the mass-energy density of the universe. The standard lambda cold dark matter model of the universe requires dark energy to explain the observed acceleration in the rate at which the cosmos is expanding. Scientists base these conclusions on measurements to distant supernova explosions in distant galaxies, which appear to be further away than they should be if the universe's rate of expansion wasn't accelerating. The problem is the present rate of expansion of the universe is increasingly being challenged by new observations. Firstly, evidence from the afterglow of the Big Bang, known as the cosmic microwave background radiation, shows the expansion of the early universe is at odds with the current expansion of the universe, an anomaly known as Hubble tension. In addition, recent analyses of new high-precision data from the Dark Energy Spectroscopic Instrument DESI has found that the lambda cold dark matter model does not fit in as well as models in which dark energy is evolving over time rather than remaining constant. Both the Hubble tension and the surprises revealed by DESI are difficult to resolve in models which use a simplified 100-year-old cosmic expansion law known as Friedmann's equation. Now, this assumes that on average the universe expands uniformly, as if all cosmic structures were put in a blender, making it a featureless soup with no complicating structure. However, that's not the way the universe is. The present universe actually contains a complex cosmic web of galaxy clusters in sheets and filaments, and these surround and thread through vast empty voids. Wiltshire points out that we now have so much data we can finally answer the question, how and why does a simple average expansion law emerge from complexity? He points out that a simple expansion law consistent with Einstein's general relativity theory doesn't have to obey Friedmann's equations. The European Space Agency's Euclid satellite, which was launched back in July 2023, has the power to test and distinguish the Friedmann equation from the Timescape alternative. However, this will require at least 1,000 independent high-quality supernova observations. When the proposed Timescape model was last tested back in 2017, the analysis suggested that it was only a slightly better fit than the lambda cold dark matter model as an explanation for cosmic expansion. So, Wiltshire and colleagues worked closely with the Parthenon Plus collaboration team, who had painstakingly produced a catalogue of 1,535 distinct supernovae. They say the new data provides very strong evidence for Timescape, and it may also point to a compelling resolution of Hubble tension and other anomalies related to the expansion of the universe. Further observations from Euclid, as well as the new Nancy Grace Roman Space Telescope, will be needed to bolster support for the Timescape model. This explanation of dark energy from Dr. Don Lincoln of Fermilab.
You know something? Science is pretty amazing. For thousands of years, people have wondered about the ultimate building blocks of the cosmos. And in the 20th and 21st century, we've made some incredible progress. For instance, if you take a bunch of quarks and you take some leptons, you take these quarks and leptons and you shake them up, you can make atoms. Atoms make up all of ordinary matter, from me to you to the most distant galaxies. In fact, our best estimates tell us that there are about 10 to the 80. That's a 1 followed by 80 zeros of atoms in the universe. They're all basically the same, and we understand them very well using chemistry and nuclear physics. However, I have some humbling news for you. If you add up all of the matter tied up in stars and planets, it only amounts to 0.5% of the matter and energy in the universe. Even if you include the hydrogen gas between the stars and galaxies that is invisible to ordinary light, you still have only about 5%. 5%. So what is the other 95%, and how is it that we've missed finding it? Scientists think that the universe is composed of 3 different substances. 5% is ordinary matter, 27% is a substance called dark matter, and 68% is called dark energy. I want to tell you about dark energy. First, I should tell you that even though dark matter and dark energy have similar names, they are really very different things. Scientists have known for a long time that the universe is expanding and have called that process the Big Bang. From what we understand about gravity, it seems clear that the expansion of the universe should be slowing down. After all, gravity is an attractive force. If I throw this ball up, gravity will pull the ball back downwards. Its motion will slow down. What we didn't know was how gravity would determine the ultimate fate of the universe. Was the universe going to expand forever without ever stopping? Expand and stop at some unfathomable distant time in the future? Or expand for a while, then have the expansion overcome by gravity and have the universe collapse in some sort of big crunch? Nobody knew the answer, and the debate raged. In order to resolve the question, we needed to understand the expansion history of the universe. And to do that, astronomers used a class of supernovae, which is the explosion of a dying star. This kind of supernovae was very well understood. If you saw one, you knew the brightness of the explosion. However, just like a distant candle appears dimmer than a close one, so too it is with exploding stars. By knowing the intrinsic brightness of the explosion and how bright the star appeared in your telescope, you could work out how far away it was. That's the first measurement. The second measurement of distance uses the same idea as a train whistle. That same drop in pitch that you hear as the train passes and begins to move away from you also shows up in the study of distant stars and galaxies. Stars moving towards you appear bluer than the same star when stationary, while stars moving away from you appear redder. The faster the star moves away from you, the redder it appears. Since distant galaxies appear reddish, they are moving away from us. In addition, we can relate their distance and their velocity. If galaxies a certain distance away are moving with a particular velocity, galaxies twice as far away are moving with double the velocity, and so on. In this way, we can measure the color of the distant galaxies and determine their velocity and then work out their distance. It's all a bit tricky, but these two methods of measuring distance are not very controversial, and they should agree. So, in 1998, 2 experiments applied these techniques and looked at the most distant supernova ever. And they found that supernovae were dimmer than predicted by the expansion of the universe. This means that the stars were farther away than expected. But that meant something even more shocking. It meant that the expansion of the universe wasn't slowing down. It was speeding up. That was really a mind-blowing observation. From what we knew about gravity, the expansion of the universe should have been slowing down. We didn't know the details, but the slowing down seemed assured, and yet that's not what the data said. In physics, data is king. If an idea disagrees with an accurate measurement, the idea is wrong. So this meant that in order for the expansion of the universe to be getting faster, there had to be some form of gravity that was repulsive. It turns out that Einstein once postulated a repulsive form of gravity in his equations. This was because he knew that ordinary matter should make the universe contract, and he needed some kind of repulsive gravity to overcome the attraction. However, when the universe was found to be expanding in the 1920s, Einstein took that extra form of gravity out of his equations. He even called it his biggest blunder. Imagine if he hadn't done that. I mean, the dude could have been famous. Now, it seems that we need a repulsive kind of gravity to explain our observations. So what is the source of this new form of gravity? It turns out that if the universe has an energy field of the right kind, it can make the expansion of the universe accelerate. This form of energy is now called dark energy. Now, to be honest, we aren't 100% sure about this dark energy hypothesis, although there are now many measurements that support the idea. Even though dark energy is the most popular explanation for the expansion mystery, other suggestions have been made. While dark energy is a constant energy density, another idea called quintessence is also a contender. Quintessence is an energy field that varies in time, and there are several ideas in contention. We need to understand that the observation of the accelerating expansion of the universe is only about 15 years old. It took a little while to assimilate the discovery and then many years to design and build new facilities to study it better. Over the next couple of years, several new observatories will begin operations to explore this surprising discovery. I don't know what the final answer will be, but I do know that anytime you don't understand 95% of something, that somebody will figure it out.
That's Dr. Don Lincoln from Fermilab. And this is SpaceTime. Still to come, the solar wind apparently slowing down once it gets beyond Pluto, and scientists have discovered that some of the oldest terrain on Venus, known as tesserae, have layering which is consistent with volcanic activity. All that and more still to come on SpaceTime. New measurements by NASA's New Horizons spacecraft has confirmed earlier data showing that the solar wind, the supersonic stream of charged particles flowing from the Sun, slows down the further away it gets. The findings, reported in the Astrophysical Journal, are providing important new insights into some of the furthest reaches of space ever explored. Previously, only the 1970s vintage Pioneers 10 and 11 and Voyagers 1 and 2 spacecraft had explored the outer solar system and furthest reaches of the heliosphere, the bubble of the Sun's atmosphere which encompasses the entire solar system. But now New Horizons is doing the same journey, and it's using far more modern and advanced scientific instruments. The study's lead author, Heather Elliott from the Southwest Research Institute in Boulder, Colorado, says the Sun's influence on the space environment extends well beyond the outer planets, and New Horizons showing new aspects of how that environment changes with distance. New Horizons is collecting detailed daily measurements of the solar wind, which is composed primarily of ionized hydrogen, that is free electrons and protons, as well as helium nuclei, known as alpha particles, and trace amounts of heavy ions and atomic nuclei, including carbon, nitrogen, oxygen, neon, magnesium, sulfur, silicon, and iron, all ripped apart by the extreme million-degree temperatures in the Sun's outer atmosphere or corona. New Horizons is also collecting data on other key particles called interstellar pickup ions in the outer heliosphere. Now, these interstellar pickup ions are created when neutral material from interstellar space enters our solar system and becomes ionized by light from the sun or through charge exchange interactions with solar wind ions. As the solar wind moves further away from the sun, it's encountering an increased amount of material from interstellar space. And when interstellar material is ionized, the solar wind picks up that material and researchers theorize slows down and heats in response. And New Horizons has now detected and confirmed this effect. The authors compared the New Horizons solar wind speed measurements from 21 to 42 astronomical units to speeds measured just 1 astronomical unit recorded by both the Advanced Composition Explorer or ACE spacecraft and the Solar Terrestrial Relations Observatory or STEREO spacecraft. By the way, an astronomical unit is the average distance between the Earth and the Sun, which equates to 150 million kilometres or 8.3 light minutes. By 21 astronomical units, it seems New Horizons could be detecting the slowing down of the solar wind in response to picking up interstellar material. And when New Horizons travelled beyond Pluto, between 33 and 42 astronomical units out from the Sun, the solar wind was measured at 6 to 7% slower than what it was at 1 astronomical unit distance, thereby confirming the effect. Now, in addition to confirming the slowing of the solar wind at great distances, the change in the solar wind's temperature and density could also provide a means to estimate when New Horizons will join the Voyager spacecraft on the other side of the termination shock. That's the boundary marking where the solar wind slows to less than the speed of sound as it approaches the interstellar medium. Voyager 1 crossed the termination shock back in 2004 at 94 astronomical units, followed by Voyager 2 in 2007 at 84 astronomical units. Now, based on lower levels of solar activity at the time of measurements and lower solar wind pressures as a result, the termination shock's expected to have moved closer to the Sun since the Voyager crossings. Extrapolating current trends in the New Horizons measurements also indicates that the termination shock might now be closer than what it was when intersected by Voyager. At the earliest, New Horizons could reach the termination shock next year. But as the solar cycle activity increases towards solar max, the increase in pressure will likely expand the heliosphere. And this could push the termination shock back out to 84 to 94 astronomical units before New Horizons has time to reach it. That's the same range found by the Voyager spacecraft. New Horizons' journey through the outer heliosphere contrasts somewhat with that of the Voyager's in that the current solar cycle is fairly mild in comparison to the very active solar cycle the Voyagers experience when they're in the outer heliosphere. Of course, right now the two Voyagers are beyond our solar system, flying through interstellar space. In addition to measuring the solar wind, New Horizons' extreme sensitivity allows it to also measure the low fluxes of interstellar pickup ions with unprecedented time resolution. If all goes well, New Horizons will be the first spacecraft to measure both the solar wind and interstellar pickup ions at the termination shock. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, researchers find some of the oldest terrain on Venus, known as tesserae, have layering consistent with volcanic activity. And later in the science report, researchers in South Korea have developed swarms of tiny robots that work together like ants. Could we be entering a brave new world? All that and more still to come on SpaceTime. Scientists have found that some of the oldest terrain on Venus, known as tesserae, have layering which is consistent with volcanic activity. The new findings could provide fresh insights into the enigmatic planet's geological history. Tesserae are tectonically deformed regions of the surface of Venus. They're often more elevated than the surrounding landscape. They comprise about 7% of the planet's surface and are always the oldest feature in their immediate surroundings, dating back about 750 million years. The new research reported in the journal Geology suggests that a significant proportion of tesserae have striations consistent with layering. The study's lead author, Associate Professor Paul Byrne from North Carolina State University, says tesserae are either made up of volcanic rocks or their counterparts to the Earth's continental crust. But he says the layering found on some tesserae isn't consistent with the continental crust explanation. Byrne and colleagues analysed images of Venus's surface from NASA's 1989 Magellan mission, which used radar to map 98% of the planet through its dense atmosphere. Scientists have been studying Venus's tesserae formations for decades, but this layering of the tesserae hadn't previously been recognized as widespread. And according to Byrne, this layering wouldn't have been possible if the tesserae were simply portions of continental crust. Continental crust, at least here on Earth, is composed mainly of granite, an igneous rock formed when tectonic plates move and water is subducted from the surface. Thing is, granite doesn't form layers. Now, if there's continental crust on Venus, then it's below the visible layered rocks. Aside from volcanic activity, the only other way to make layered rock is through sedimentary deposits, things like sandstone or limestone. Problem is, there isn't anywhere on Venus today where these kinds of rocks could have formed. The surface of Venus is hot enough to melt lead, and it has 100 times the air pressure at sea level on Earth. So the evidence right now points to some portions of tesserae being made up of layered volcanic rock, similar to what's found here on Earth. Either way, the study's hoping to shed new light on Venus's complicated geological history. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have identified a new genetic link to autism spectrum disorder. A report in the American Journal of Human Genetics has identified a previously unknown gene variant on the DDX53 gene on the X chromosome, which appears to contribute to autism. The disorder, which affects more males than females, encompasses a group of neurodevelopmental conditions that results in challenges related to communications, social understanding and behaviour. The findings are based on research on 10 individuals with autism spectrum disorder from 8 different families and found that variants in the DDX53 gene was maternally inherited and present in all the individuals. While DDX53, located on the X chromosome, was already known to play a role in brain development and function, it was not previously definitively associated with autism. Following the recent wet La Niña years with widespread flooding, today's drier conditions have resulted in a drop in waterbird numbers and breeding in 2024. The University of New South Wales annual waterbird survey has observed fewer waterbirds breeding and a drop of nearly 50% in overall numbers compared to 2023. The researchers spotted 287,231 birds in this year's survey. That's down from 579,641 birds in 2023, ranking this year approximately in the middle of the 42 years that the survey's been running. Scientists in South Korea have developed swarms of tiny magnetic robots that work together like ants to achieve truly Herculean feats, including traversing and picking up objects up to 2,000 times their size. The engineers testing the microbots found that swarms could climb an obstacle 5 times higher than a single microbot, and they could hurl themselves one by one over an obstacle. Swarms of 1,000 microbots could wrap around a pill weighing 2,000 times the mass of an individual microbot and transport the drug through liquid. Another swarm of microbots managed to transport cargo on dry land, which was 350 times heavier than each of the individual microbots. The research, reported in the journal Device, suggests that these microbot swarms could operate under a rotating magnetic field, and they could be used to tackle difficult tasks in challenging environments that individual robots would struggle to handle, such as offering a minimally invasive treatment for clogged arteries or precisely guiding organisms. The world's largest consumer electronics show, CES, is on again in Las Vegas. With the details, we're joined by Alex Zaharov-Reutt from TechAdvice.life.
LGs have recently commercialized their transparent OLED television.
It's a product that no one really wants at this stage.
That's right. Now, interestingly, LG is going to release a fridge with a transparent OLED door. So this allows you to see through the door inside of the fridge. Now, the front of the display is like a giant tablet.
So it saves you from opening the door for 10 minutes and looking at what's inside to see what do I really want to eat.
That's right. And you also have cameras in there that can use software and AI to tell you what sort of meals you can create with the contents of what's in your fridge. I mean, look, that is a useful reason to have a transparent screen, because obviously you can make a fridge just with a transparent panel. You don't have to have a display in it. But when it's a display, it can be used as a tablet. It can show you information. And so that is interesting. And, there's going to be microwave ovens with multiple cameras inside, so you can see the cooking process and see if it's cooked before you open the door. I mean, look, manufacturers are trying to think of ways to incorporate AI and modern tech into devices that just do very simple things. Keep food cold, cook food. So we're going to see a lot of creativity.
There's some news from Nintendo as well.
Nintendo has announced that it will launch its Nintendo Switch by the end of the financial year for them, which is March the 31st. So if you've just bought a Nintendo Switch, it's almost basically out of date. And if you haven't bought one but want to get one, wait for the Switch 2.
And something to make me feel really old, the flip phone turns 29. I had one of those.
It was a lot of fun to have the original flip phone. This was on January the 3rd, 1996. So it's 29. It was actually designed based on the communicator that was seen in Star Trek. So it was just under 100 kilograms, a clamshell flip phone. It couldn't send SMS, it could only receive them, and it's the equivalent of about $1,600 in today's money. Blast from the past, but what you won't even connect to a phone network today.
Apple's Vision Pro, it's gone bye-bye, at least for a little while.
Yes, look, it was listed by various tech publications as one of the big flops of last year, of 2024, and not because it didn't work. I mean, it worked beautifully well. I've had one on my head and it's quite incredible. But the problem is it's heavy and it's expensive. I mean, in Australian dollars, it's about $5,000-6,000, and in US dollars, it's about $3,500. So, more than what you pay for a traditional iPhone. Now, Apple is said to be working on ways to make it lighter and cheaper, but I've read reports that they're flummoxed on exactly how to do that because all the components are so expensive. So the word is that Apple has ceased production of the current Apple Vision Pro 1, and we'll just have to wait and see what they come up with, hopefully sometime later this year for version 2.
And last but by no means least, Microsoft have announced their own version of Apple's Mac Mini.
Yes, now there have been a number of these small mini PCs over the past few years copying Apple's Mac Mini, but what sets these ones apart is that they will have the ARM processor inside, which is what we see Apple doing with its current range of Macs, where they've taken the iPhone chip and supercharged it to become a chip capable of running desktop applications and more. And so Microsoft hasn't had mini PCs running ARM and running Windows 11 and this new Copilot Plus capability, which is where all the AI is baked in. We're expected to see a series of these mini PCs with the ARM chips arriving, which should turbocharge this category because it'll be a cheap way for people to get into this small mini PC that's running Windows 11 and running ARM and using very little power, doing all the things that Apple promised with its Macs. And it's also going to be coming on what is effectively Microsoft's 50th year of existence. Their birthday is April 4, 1975. Interestingly, Apple is April 1, 1976, so they're 49 years old.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.